Is just the office drawing. If you want to, you can also open up the top drawing. And we're also going to need something to take some notes on. And that's pretty much it. So first thing we're going to talk about is our office switching. So for every room, every room's entry or exit shall require switching. So even if it only has one door, you have to have switching there. The only two exceptions, or three technically, because we have two hallways, but the only three exceptions to that are going to be our lobby and the hallways. So looking at both of those scenarios, all those offices that tie into the lobby, like you shouldn't want to walk out of your accounting office and turn off the lobby lights, right? You want to keep the lobby lights on so that way when people enter the building, they come talk to you, the lights are on, right? They can see where they're at. So really that's kind of like the only exception where you don't have to have switches at every door. Same kind of thing with like the hallways. Well, if you're walking in to go use the restroom from the hallway, you don't really want to turn off the light in the hallway, right? Because that's just the hallway doing its job connecting all those rooms together, but you would want to have the hallway constantly lit until you're ready to go home at the end of the day. So really those are our two exceptions. Every other room, all their entries and exits are going to require switching. So we'll have a little bit of review kind of from motor control / your code class. But if I only have one door, one entry, or one exit, what kind of switch am I going to use to control those lights? That's half of it. It essentially is just like the toggle switch, right? Up and down. But what's the, kind of going back to motor controls, what's the one-way technical definition of it? Close.
Three-way?
Huh?
Three-way?
No, we're not there yet. We're not there yet. But you were saying it, single pole, not double throw.
Single pole.
There you go, single pole, single throw. So, for rooms that have just one entry or one exit, the symbol we're going to use for our switches is kind of just basically a money sign. But in terms of ladder logic, that's just our single pole, single throw switch. And of course, we would have multiple lights in parallel. I'm just drawing one, but you kind of get the idea. So we'll use our single pole, single throw switch. For rooms that only have one entry or one exit. But what if I have exactly 2 entries or exits into a room? Then what kind of switching would I use?
3-way.
3-way, there you go. So, our symbol doesn't change that much. We still kind of have that money sign, but now it has a little 3 next to it. So, in terms of ladder logic, gotta look at that. We now have these 2 switches, so both switches have this common point, right? So we're bringing L1 in to a common point, and then we can toggle between these 2 terminals. Same thing with this light, it's just flipped around. You toggle between these 2 terminals, and you have a common point that then goes out to all of your lights. So no matter which entry or exit you enter or leave from, you can turn on or off one of these switches and activate your lights. So this would be a scenario where if a room had exactly 2 doors, we use 3-way switching. But let's say we have more than 2 doors. It could be 3, it could be 4, it could be 5, it could be however many doors, but we have more than 2. What kind of switching would we use then? 4-way, right? What's the one important thing with 4-way switching? You have to remember. You have to use 4 ways, and what other kind of switch? There has to be 2 3-ways in there, right? So, looking at our 3-way example here, we have to have these common points for the entry and the exit, basically, coming in and going out. All the switches in between are going to be our 4 ways. So, schematically for us, again, that symbol's not changing a whole lot. Still got our money sign, but our 4-way switch has a 4 next to it. So, in terms of ladder logic, if we were actually going to wire this up, we would specifically need to start with our 3-way switches. We have to have that 1 entry or exit. Then you could put as many 4 ways, sometimes called a cross switch. You can put as many 4-way switches as you need or desire. It does not matter. You could have 5 or you could have 500 4-way switches. It does not matter. But however many 4-way switches you put, those all kind of need to be in the middle, so to speak. And once you get done with your switches, you have to have this other 3-way here at the end. So, I'll draw little boxes around these. So you're going to start with the 3-way, and you're going to put all your 4 ways. In this example, I'm doing 2 here. And then you'll finish with your last switch as a 3-way. So, because if we just look at this 4-way switch, if we only put 4-way switches, we now have 2 terminals here on the left-hand side, right? We would have 2 inputs. Well, we only got 1 line 1, so we can't use, and kind of the same thing on the, if we used it at the end, we would have 2 outputs, right? We don't want that, so we need to consolidate that down to a single input with this first 3-way and a single output with the last 3-way. So you have to use 2 3-way switches if you're going to use 4-way switching. You have to. If not, you can't get it to work. So, like I said, you can put 1, you can put 2, you can put 500 4-ways in the middle between these 2 3-ways. It does not matter. There's no limit there. But you have to have those 2 3-way switches.
And that's just for rooms of 2 or more, more than 2 doors?
Correct. More than 2 doors.
So if it's 3, we just need to put 1 as 4?
Correct. Now, like I said, if we were to physically wire this up, our ladder logic here, that would be very important to us, because like I said, we would have to physically bring the line one in here to switch 3, then go to all of our other switch 4s, and then finish with switch 3 again, going out to our lights. But thankfully, we're not wiring it up, we're just kind of doing a drawing of it. So our drawing is, again, that kind of that bird eye or top down kind of view. So where we physically put those switches in the room does not matter, but like in this room, for example, it doesn't matter where I place my 3-way switches, as long as I have those 2 3-way switches. So I could say, like right here, draw it, that would be a 3-way, maybe another one over here, right? It doesn't matter where you put them at, then the rest of these would all be your 4-way switches. So it doesn't matter where we draw them on here, because again, our view is just down. It's not a wiring diagram.
So he was saying if you have 3 doors, what do you do?
So if you have 3 doors, you still have to use 4-way switching, but you have to have these 2 3-way switches, and then you would only have 1 4-way switch for 3 doors, right?
And then for counters and all that, like in the middle of the lobby that don't actually exclusively.
Yeah, I guess that's also kind of an exception, but these doors right here are kind of the only exclusion to that. But that go behind the counter.
So the ones that go to the hallways, those aren't excluded, excluded?
No,
Okay.
no, just those doors right there at the countertop. Because like I said, that countertop is just like a little half wall, and those doors there, that's just to kind of prevent whatever, people off the street kind of. Yeah.
Can you, say that again, why you put the S3 on those 2 doors?
There's not a reason on there. It doesn't matter where you put them, but you have to have those 2 3-way switches. You have to. Everything can't just be listed as 4. Because ladder logic, it will not work. Right? So it doesn't matter where you put it. You can put it on this door and that door, this door and that door, this door and that door. It doesn't really matter. But you have to have those 2 3-ways. So is everybody good with this review over the switches? Would y'all like to see this put into practice? A couple of examples? Okay. So, like I said, kind of piggybacking off of the stuff that we did from last week. Of course, your office should have all your lights in there. So the first thing that we want to do is on your layers is you're going to turn off the lighting circuit home run and the lighting dash. So we do not want the little tags and we don't want the purple dashed lines on there. All we want are just the purple rectangles, just the lights themselves. Excuse me. So you gotta notice over here I have a couple of lights just drawn in. I don't know if this is right, wrong, or otherwise for how many lights. They're definitely not spaced out evenly. I just kind of put them in there by hand for example purposes. But if we gotta look here, this is one of our storage closets here, but we have only 1 entry or 1 exit. So what kind of switching do y'all think we were gonna use here? Single pole. So, what we're gonna do is, if you kind of flip down your layers again, you'll notice that there's 2 layers here, switches and switches dashed. So, just like a lot of the other things that we've drawn into our project so far, we'll start on the switches layer. If you go to your insert tab and insert block in your block library, if you kind of scroll down in here, you'll notice that the single pole, the 3-way, and the 4-way switching, just like what we all talked about over there, are already in your library. So you don't have to make those symbols, they're already pre-made. So we'll just grab the regular single pole switch here, and really the only requirement for the switches is not to place them on hinge sides of doors, right? We don't want to put this switch on the hinge side of the door. cause then you'd have to open up the door in a dark room and then go behind the door and try to turn on the lights. So you wanna put it on the opposite side of your hinge side. And as far as the spacing requirement, there's not one off of the door. You just put it in as far as what you think looks good. So like right there, I don't know what that distance is, there's not a required distance, but that looks pretty good right there to me. So once you install the switch, you're then gonna go over to the switch's dash line layer, and you're simply gonna take a line, and you're gonna tie together the switch or switches to what lights they are controlling. So in this little storage closet example, I only put one light in there, so this single pole switch controls just this one light right here. If I kind of move over a little bit, yeah.
You have it buttered up on the wall just cause,
What do you mean?
you said it doesn't matter, right, where you put the switch, you just have it buttered up.
Well, you have to put the switch on the wall, right? But I'm just saying, like, as far as the distance, like off of the door or anything, there's not a distance this direction on there. You know, unlike receptacles, you know, like how we had all the spacing and everything, none of that really is kind of applicable for our switches. You can just kind of put your switch where it looks decent, you know, on your drawing, but there's not a distance requirement. The only requirement is, like I said, we don't wanna take this switch and we don't wanna have it on this side, on this specific example, because that's the hinge side of the door, right? But, if I kinda scroll over here, I think this is one of the executive offices here. Got a couple of lights drawn in there, but now we have 2 entries and 2 exits. So, this is exactly 2, so what kind of switching would I use in this room? Three-way, right? So very same process, except now I'm taking my 3-way switch. Again, I don't wanna put my switch over here, because this is on the hinge side of that door, so I'll put it on the bottom side of this door here. And as far as the rotation of the switches, I kind of just treat like what would be like the bottom, so like, whoops. There you go. So I'm just gonna temporarily kind of show this here. But kind of like whenever we did receptacles, remember how we had those prongs? I would kind of consider like, you know, the bottom side of this switch, you know, like theoretically, like those the prongs of the receptacle, right? So you want to have those kind of facing perpendicular in every direction. So whenever I place my switch here, I'll want to turn it to the side, so it kind of faces that direction. So there's my first 3-way switch. Coming over here to this door, I don't have to worry about a hinge side, so you could technically put this switch on either side of this door, but we'll need another 3-way. So there's my 2 3-ways. And again, we'll want to take this dashed line layer and connect all the switches to all the lights that they will be controlling. So, something very similar to this right here. So you should not be utilizing that purple dashed line from last week. That was for us running power out to the lights. Now we're kind of splicing in there, and we're gonna have this separate dashed line just for our switches. So you do have to redraw these dashed lines in this blue layer here.
And then for the double doors, you can't really avoid having it on the inside. What do you do there?
Correct, just do the best you can.
Okay.
Yeah. I'm gonna talk about those here in a second.
Okay.
move into this office just to the right of that, here we have multiple entries and exits with all these 4 doors. Got a couple of lights in there. So this would be an example of where we have to use our 4-way switching. So again, the first thing with 4-way switching is you have to have 2 3-way switches. So it doesn't matter where those 2 3-way switches are placed, but you do have to have those 2 3-ways. So I'm gonna put one of them kind of over here by this door. And let's just put the other one across it from it. Again, there's not a specific right or wrong where the 3-way goes. So there's my 2 3-ways. So this top and the bottom set of doors, those are gonna be, the rest of those are gonna be our 4-way switches. So this is where we would use our 4-way. And same process, once you get your switches drawn in, you're then gonna connect all the switches to all the lights that they will be controlling. So, something similar to that right there.
Can you go back to the, how the other one looks, the one we did just before?
The 3-way?
Yeah.
Mhm.
Thank you.
Mhm. So, y'all feel a little bit better now on how to draw in the switches?
Can you give an example of how to do the receptionist?
What do you mean? So the receptionist is still gonna require switches at all these doors, except these 2. These 2 are not gonna require switches next to them.
Are there any more like funky looking doors that we have to look out for?
Other than just like, for example, here in the lobby, you know, like I told y'all, don't put a switch on the hinge side of the door. Well, it's kinda hard here, right? Cause they're double doors and these actually are facing the incorrect direction. That's kind of a funky scenario, kind of the same thing repeats up here. Same kind of thing over here in the communications room. I'd say probably the only other kind of weird situation is this little break room. Like you don't need switches on these other side here in the break room to turn off the break room lights, right? Like if you're gonna walk into the mechanical room or the storage room right here, you don't need a switch right here or there to turn off the break room lights, right? So, I mean, other than that, pretty much every other door is gonna require switching at
But do
every
we,
entry and
do we
exit.
put switches in the lobby? Cause it says exceptions for the lobby and hallway.
That's for every entry and exit. You're still gonna have 3-way switching in the lobby. So you'll have one here at this set of double doors coming in, and we'll go ahead and put another 3-way switch at this other double doors up here. But like I said, all these offices that kind of tie into this lobby area, you shouldn't need to like walk from the lobby into here and turn off the lobby lights, right? Because we want these lobby lights on all the time. So we'll put a switch as soon as you walk in. Whoever opens up the building can turn on the lights so they can walk across. And we'll keep one over here just in the event if we do need to turn it off for whatever reason, you know, other than going up to the front door, sure. But all these other rooms that tie into the lobby do not need switches at every entry and exit.
So for that executive break room, you only need one single pole, single throw, because you're excluding the other 2 doors?
Nope, these 2 doors still require switches,
Okay.
and this one. I'm just saying you don't have to have switches at these two doors to control the executive break room lights, right? So, like I said, kinda think through this process, like, well, if I was standing in this room and I was gonna go into this closet, do I really need to turn off the lights in this room, right? If this is my only way into this room right here and I can't leave, you know, I'm gonna have to walk back out through here, so I don't wanna turn off the lights on myself, right? So, like I said, you can kinda walk yourself through some of those processes, but for the most part, every entry and exit is going to require a switch. Somebody else have a question back there? Thought I saw a hand.
No, that one was answered.
Okay. So is everybody good with the drawing portion for your switches? Okay. So, for the office switching, there are no calculations involved with that. There's nothing in your notebook that you need to show what we just talked about in this drawing right here. So, the only thing for the office switching is just right here what I just showed you, applying this logic right here to that. See, I can be nice sometimes. Don't need it. Alright. So everybody's good with the office switching? Okay. So we're gonna kind of switch gears just a little bit. We're gonna talk real quick about our shop switching. So, I don't have any of my shop lights drawn in here, right? But last week, when we were kind of talking about all of our lighting stuff, we came up, did a group activity with our shop lights, and we determined that we need 12 shop lights in there. So we installed the 12 lights, and we also installed that lighting panel. So, y'all remember what voltage our shop lights were? Divide that by square root of 3. Y'all ought to know 480 divided by square root of 3. What was it? 277, right? So, our shop lights are running on 277 volts. And it's in a commercialized / industrial kind of facility, right? How many of y'all work or have worked like an industrial kind of facility before? Okay, how many light switches did you see on the wall? None, right? So, same thing, very similar thing when I was at the power plant. Kind of comparing apples to apples as far as the power plant to our project. Both were a 24/7, 365 operation, right? We don't have windows in here. Yeah, we got some exterior doors, and we do have a roll-up door, but that's not enough natural light. So every day of the week, every hour of the week, we're gonna have the lights on in here, especially if we're running 24/7. So where I'm going with this is again, in those industrial environments, you didn't have switches on the wall. Part of that is for safety, so I guess they kind of know how technicians are sometimes, but let's just say like if your buddy's working over there on something, you're like, oh, I'm gonna turn off the lights, you know, and you turn off the lights real quick and then turn them back on. You know, it might be funny between you two, but somewhere off in the plant, in that same room, same building, somebody may have been carrying some boxes, and you turned off the light and they couldn't see where they were walking. Next thing you know, they trip, fall down, and break their leg, right? It's not funny for that guy, right? So to kind of prevent some stuff like that, we don't have light switches. And again, there's no need to turn off the lights, right? So I have a couple of code references here. You don't have to write these down by any means. But ironically, if we look in 240 at dot 83, specifically as delta, so 240.83 delta, it's talking about marking for switches or uses as switches. And it allows us to say circuit breakers used as switches in 277 volt lighting circuits shall be listed and shall be marked as SWD or HID. So we can use our breaker as a switch, which honestly kind of makes a lot of sense for us, right? We're going to be running 24/7, 365. The only time we're going to need to turn off the lights in the shop is if we have to do maintenance on them. And if we're going to do maintenance on them, we're going to be locking and tagging the stuff out anyways, right? So, and to even kind of further that, flip back here real quick. We can also use code reference 404.11 to back this up. Again, 404 is talking specifically about switches, and 11 is talking about circuit breakers as switches again. And it says, a hand-operable circuit breaker equipped with a lever or handle, or a power-operated circuit breaker capable of being opened by hand in the event of a power failure, shall be permitted to serve as a switch if it has the required number of poles. So ours has the right number of poles. So again, we can use our circuit breakers as switches. So what that translates to y'all, as far as your shop switching goes, is when we drew the lights in last week, we tied them all together with that purple dashed line, then put the tag on there and pointed it back to the panel. You simultaneously already did the switching drawing, right? So for our shop, for our shop, there are no calculations or really any drawings to do for the shop switching, because we already completed that, again, via those lighting circuits that we drew in the shop last week. So, shop switching is a lot easier. Does anybody have any questions over the shop switching? No? Is everybody good with the office switching? You guys good with that? That's it. Yeah. So looking at our schedule, again, we're physically in week 7, but we're covering week 6 material again, because I kind of split that week 3 out. But that's all that's on our agenda for this week, is really just